This video we go over chapter 11, problem 7. Some of the textbooks have this as problem 7. In my textbook it's problem 6. If you did this problem, this is the solution to it. The first one is they give you a forecast and they tell you what the capacity is. So I went ahead and put the capacity not as a single number but as an array because it changes in the last time period. So in general you can just put in capacity for every month and then compare what you do in regular time against the capacity. We have two choices on how we do things. We can either make things in regular time or overtime. The cost is $40 per unit, and then it's time and a half for overtime. And the first one, they want you to implement a chase strategy. Chase strategy means make demand. So whatever demand is, that's what you make. So that's capacity. I mean, that's forecast. So that's what you make. This is forecast, so you make 300. You can only make 275, so you have to split this out. We have an inventory position formula. It's equal to what you start with plus what you make minus what goes out the door. One indicator of a chase strategy is that inventory is always 0. So if you implement this, this is what the cost is, 78500. In part B, I don't really understand the problem. Other than there is, they replace the overtime with a subcontractor, and the subcontractor is cheaper. If you do that, I get the exact same solution. You can use inventory, it does say, but I went ahead and did the exact same thing where I just changed this, so my plan did not change at all. I did exactly the same thing, except it's a little bit cheaper because the unit cost is cheaper than overtime. But then I went back to the original problem and I set it up so that I have inventory, a cost of inventory at $2 per unit, and I use solver. So this last one down at the bottom is the optimal, and when I set this up, I'm trying to take my cost, which is a sum product of my regular time, overtime, and inventory position totals against the unit cost, 40, 60, and 2. I'm changing these cells. I'm letting the model have control over these 14 cells. And then I have two sets of constraints. One of them is that my regular time usage has to be less than or equal to my capacity, which is identical except in the last month. In month 7, it can't be more than that for regular time capacity. And I also have a constraint that says my inventory position has to be positive or not negative. That way I don't have any back orders. If you set this all up and then hit solve, oh, and make sure you use this the simplex LP, which is assuming that you have linear equations, which you do, you hit solve. This is what it turns out to be. I found a solution that is cheaper than this one. What it does is you still use a little bit of overtime, but you do build ahead some inventory and bleed it off. So when you go from a demand of 250 to 300 and then 250 to 300, it's telling you that rather than using overtime to do that, since you're only carrying inventory for one time period, it's worthwhile to use regular time, build up some inventory and bleed it off and do that twice. After that, it's not as useful, so you wind up using overtime to handle things after the fact. Okay, that's what I've got. Thanks.